Okay, in this tutorial we're going to take a look back at the 3D vectors that we looked at in an earlier lesson, where we were taking the coordinates of one position and the coordinates of the other, and we were finding the components for the vector that would go between them. Alright, so we're going to do that in this lesson, except now I already have a cone and a sphere in the scene, and what I'm trying to do is to find the magnitude, the distance between these two objects here. It's going to be between that orange dot there and that orange dot there, which is the origin of each one of those objects. Alright, so the way we had done it, we'd gotten before when we were using the cube example, we had the coordinate of the far corner of the cube, and we subtracted the coordinates of the other coordinate, of the other corner of the cube, and that gave us the components for the vector. So I'm going to do the same thing in here, but since I don't know the coordinates right offhand, in the Python code we can actually get that. And so I've prepped this up, and this is the reason for doing this is so you have access to all these type of files, so you have a reference if you want to use it within your own code in other applications. So what I have here is within the main method, I'm just getting the cone. So I have that, I'm using the scene alias that I had up there. So the cone is equal to scene.objects cone, because that's the name of my cone in the scene. And then that's the name sphere. So for that object, I just get the sphere is equal to scene.objects sphere. So those are the names. And then what means that wasn't working earlier because I had forgot to set up my game logic on my cone. No, or my sphere. Alright, so then to get the coordinates, now earlier remember we had printed a position of an object by just saying print the object dot local position dot x. I was showing you the x coordinate. Well, you can get dot y and dot z, but in this case I'm using it in reverse. So I'm assigning the local position dot x of the cone to this name x cone, and then y cone and z cone for the y and z positions as well. Alright, so I could actually, I don't need to do this step, but this simplifies it for just keeping it concise. And then I do the same thing. I get the x, y, and z positions, or the x, y, and z coordinates of the sphere, and then I assign it to x sphere, y sphere, and z sphere. Alright, so in this case I'm going to look for a vector between the sphere and the cone, so I'm going to subtract the coordinates of the sphere from the coordinates of this cone, and those would be the components of the vector. So that's why I call this the x, y, and z component is going to be x sphere minus x cone. Well, I did it the other way around. It doesn't really matter actually because it's still the distance in between. And then y sphere minus y cone and z sphere minus z cone. Alright, and that gives me a component to the vector that goes between those objects. And because the reason it doesn't matter is because when we take the magnitude, remember it's the square root of the x component squared, and so that squared term and the y component squared and the z component squared, so the squared term is going to take care of any negative values we have in there. And then I create a vector. Now this is a vector command built into the math utilities, so I call it a new vector is the name, and I create the vector based upon those components that we created. And so I'm going to print that out, and then instead I use a built-in function within Python to calculate the magnitude of the vector, and that function is called getDistanceTo. So you supply, it's kind of like the angle between vectors that we use, but in this case we just supply the name of an object and then dot it with getDistanceTo, which is the command, and then provide the name of the other object that we're looking for, and I return that into this magnitude right here like this, and that's what I'm going to print. Distance from the sphere to the cone is the magnitude like that. So I'm printing the magnitude and I'm printing the vector components as well that I've created. Now you might wonder why then we had to go through the whole process of the 3D vectors to calculate the distance between two different pair of coordinates instead of just using this command directly. Well, that's because it's important for us to know the mathematics, what's going on behind the scene, because that will come into play into many other applications in the future. Alright, so a lot of these tutorials that I teach are based on making sure we're grounded in the mathematics as well as being able to use the commands that are just automatically built in for us. Alright, so let's run it and see what happens. So I'll run it, and then I'll go look at the console window, And it shows right here, here's the distance from the sphere to the cone. It's just running over and over again. And it shows the vector components as, negative 5.9, negative 7.2, and negative 2.4. And that's because if you were to move this object in x, let's see, negative 5.9, it'd be negative 5.9 in this direction would bring you back to this x coordinate, and then negative 7.2 in y would bring you back to this coordinate, and negative 2.48 down would bring you back to the z coordinate here, would bring you back to that location. And then I use the getDistance2 function to calculate the actual distance between the objects. Well, let's see if it actually changes. Let's bring this down here quite a bit and bring it over, and we'll get it pretty close. And let's just see how far that dot is from that dot now. I'll rerun it. And now it shows, here's my vector components have changed significantly, and the distance is only 1.239. Now let's see how powerful this distance function is and see if it actually is smart enough to recognize when it's right on top of each other. So I'm going to press Shift S cursor to selected because I have this sphere selected, and then I'm going to get this. I'm going to press Shift S and I'm going to move this selection to the cursor. Now my origin of both objects are sitting directly on top of each other. So now theoretically my vector component should be 0, 0, 0, and my distance should be 0 as well. So let's see when I run it, and there it is, 0, 0, 0, and the distance from the sphere to the cone is 0, like that. So this is a really helpful function. Now, especially because you might imagine that when we get up to doing the missiles, this might be our Scud missile being launched at us, and this might be our Patriot missile being launched back towards the Scud missile, like this. And I want to know this distance in between here at all times. Okay? All right, well that's it for this lesson, and I'll see you in the next lesson.